Now in this video, we are going to take up one more problem on projections of solids. How to analyze this problem and solve this manually. The problem reads as a square pyramid 35 mm sides of base and 60 mm axis length rests on HP on one of its slant triangular faces. Draw the projections of the pyramid when the axis appears to be inclined to VP at 45 degrees. To do this, here, first, since it is a square pyramid resting on one of its slant triangular face, make the slant triangular face perpendicular to VP. So you can see that the slant triangular face is perpendicular to VP here in the front view. That is the reason why you are getting a line in the front view. How do I know that it is a triangular face? When you look from the top view, you can see this O dash, B dash, C dash. And the shape of this in the top view is OBC, which is a triangle having, since it is perpendicular to VP, so you are getting a line in VP, and since it is inclined to HP, so you can see there is a triangle here. There are two triangular faces which are perpendicular to VP, that is O dash B dash C dash is one, and O dash A dash D dash is the other one. Since it is both the sides of the triangular face, either you can rest it on left side or it can be rested on the right side. This is how you will be able to analyze this problem in the initial position, how to keep that initial position. Note that whenever it is a triangular face is resting on HP, that the edge containing the triangular face has to be perpendicular to VP always. So now, how to start this problem? First you draw the XY line and you mark VP and HP. Then you measure 35 mm and draw a square of 35 mm each, and you mark these points as A, B, C, D in the top view. Then join the diagonal AC and BD with the dark lines. So all these things which is been drawn by using the dark line, and you mark this point as O and O1 in bracket. Now from the XY line, you measure 60 mm and draw a horizontal line, and draw a vertical projector from A and D to the XY line, and similarly from B and C to the XY line. And from O1, you draw a vertical line and above the XY line by 60 mm, and you mark this point as O dash. As you look from the front view, AB is near to the observer, so A dash, B dash is visible, and C and D is away from the observer and it is coinciding with A and B. So therefore, you will going to get C dash in bracket and D dash is in bracket, and O1 dash is also on bracket. Then you O dash and A, as you know, this OA and OB are joined, and similarly OC and OD. Therefore, join between O dash and A dash. O dash is visible, A dash is visible, so visible to visible is visible. O dash is visible, B dash is visible, so visible to visible is visible. And join dark between O dash, B dash, and dark between A dash, B dash. But O dash, C dash and O dash, D dash are invisible edges, but always the preference has to be given for the visible edge. Therefore, we need to consider that by using the dark line only. Then you mark this as big dash and small dash, which is O dash and O1 dash. Once you know that, now, so this is how we will be able to write the initial position of the top view and front view of a square pyramid. Now, then he says one of the triangular faces is resting on HP. So I am resting O dash, B dash, C dash is on XY line. Since it is resting on O dash, B dash and C dash, so we are rotating in clockwise direction, and the same way you can rotate in anti-clockwise direction also, because this side is also a triangular face. So since I am rotating in the clockwise direction, so B dash, C dash and O dash is on XY line. How to do that? By using the compass, you measure the distance from O dash to B dash, and you take any convenient distance from this vertical projector and you mark that point as B dash and C dash in bracket. Then by using the by using the compass, you measure the distance from O dash, B dash, C, and from B dash you cut an arc on the XY line and you mark that point as O dash. Similarly, you measure the distance from B dash to A dash, and from B dash you draw an arc. Similarly, you measure the distance from O dash to A dash. From O dash, you cut on the previous theta arc. You mark this point as A dash and B dash in bracket. Then you join between A dash to B dash to O dash, and O dash to A dash with a dark line. Similarly, you measure the distance from B dash to O1 dash. From B dash, you cut an arc on B dash A dash line and you mark that point as O1 dash in bracket. Then join between O dash and O1 dash with a big dash and small dash line, which is the axis line. Now to this I need to draw the top view. How to do that? Draw a vertical projector from B dash and C dash to the top view, and similarly from O dash to the top view, and draw a horizontal projector from B and C. Both these two lines will going to intersect at these 2 points. You mark that point as B and C. Similarly, you draw a horizontal projector from O and also the vertical projector from O dash. Both these two lines will going to intersect at this point. You mark that point as O dash. Similarly, you draw a vertical projector from O1 dash to the top view, and from O1 from the first position top view, and we mark that point as O1. Similarly, draw a vertical projector from A dash and D dash to the top view, and draw a horizontal projector from both A and D. These two lines will going to intersect at these 2 points. You mark these 2 points as A and D now. Then join A to B, B to C, C to D, and D to A with a thin line, and join between OA, OD, OB, and OC. Similarly, since it is O1 is the axis, draw a line with a big dash and small dash till to the O1. Now you apply the condition of visibility. All the exterior edges of the boundaries of the solids are visible. So you dark between BC, BA, OA, OD, and DC with a dark line. So then, as you look from the surface near to the observer is visible. When you look from the top view, you can see that entire A dash, B dash, C dash, D dash is near to the observer. So A, B, C, D is visible. A to B, B to C, C to D is already visible. Therefore, D to A should also become visible. So you dark them. Once you do that, then 2 visible edges can never cross each other. So you join between OC and OB with a dotted line, because OC is crossing the visible edge AD. Similarly, the BC, OB also. So these 2 lines will going to become the dotted lines, because the 2 visible edges can never cross each other. I cannot have OC and OB with a dark line, because AD is dark. Therefore, OC and OB has to be an invisible edge, because 2 visible edges can never cross each other. So once you do that, now we go for the third position. As the triangular face is resting on HP, then what happens? The axis will going to become inclined to HP. Since the axis becomes inclined to HP, so you are getting the apparent length here, which is O1. So what I am doing is I am rewriting the same sketch here. So since the line the axis line what you have in the second position top view is the apparent length, and since it says it appears to be inclined, so naturally the inclination given in the third position of the axis in the solid is a apparent inclination from the projections of lines on the surface on the apparent inclination line. You have to get the apparent line. Since the second position top view has got the apparent line, and the inclination given in the third position top view is apparent inclination, therefore rewrite the same sketch on the 45 degree line. So what I need to do is you consider any horizontal line, and you consider any point on that horizontal line. By using the protractor, you measure an angle of 45 degrees with respect to the horizontal, and then they draw an inclined line. Then by using the compass, you measure the distance from O1 from the second position top view. With OS center, cut an arc on that 45 degree line. You mark this point as O1. Similarly, you extend this axis line. Then you measure the distance from O to this point. From O, you cut an arc on that. So with reference to O1 line, by using the protractor, you draw a perpendicular. Okay. Then you measure the distance from this point to B and also from this point to C, and you transfer from this point towards the bottom side, which is B, and again from this side, which is C, and you mark this point as B and C. Now you mark this point as O1, then you measure the distance from O to this point, and similarly you transfer it from O onto this and draw a perpendicular to this inclined line, which is the axis line, which is then you measure the distance from this point to D and also from this point to A. Both will going to have the equal distances, and transfer it from this point towards the top side and also towards the bottom side. You mark these 2 points as A and D. Then rewrite the same sketch including the visible edges and invisible edges of the second position top view onto the third position top view without changing anything. Then I need to draw the front view. So to do that, draw a vertical projector from O to the XY line, draw a horizontal vertical projector from B to the XY line, and draw a vertical projector from C to the XY line. You mark these points as B dash, C dash and O dash. Draw a horizontal projector from O1 dash from the second position front view, and draw a vertical projector from O1. Both these two lines will going to intersect at this point, and you mark that point as O1 dash. Similarly, draw a horizontal projector from both A dash and D dash to the third position front view, and draw a vertical projector from A and D. Both these two lines will going to intersect at these corresponding points, and you mark those points as A dash and D dash, and you have O dash. Then join A dash to B dash to C dash to D dash, and D dash to A dash with a thin line, and join between O dash to A dash and D dash to O dash. Similarly, O dash, B dash and O dash, C dash is already joined, and you join between O dash and O1 dash with a big dash and small dash line, which is the axis line. Now you apply the condition of visibility. All the exterior edges of the boundaries of the solids are visible. So dark between O dash to C dash to D dash to A dash, and A dash to O dash with a dark line. Once you do that, then the surface near to the observer is visible as you are rating the front view for this third position top view. So naturally the entire surface ABCD is near to the observer, so it is visible. So we have already having B dash, C dash, D dash and D dash, A dash is visible edges, and you dark between A dash, B dash is also with a dark line. And then once this A dash, B dash becomes the visible edge, and this O dash, D dash is crossing that visible edge. So applying that, the two visible edges can never cross each other. So therefore D dash, O dash has to be an invisible edge, and you make a dotted line. So this is how you will be able to write the solution by using the sketchbook. How do I know that my problem is right? Even in the final position, you can see that the triangular face is resting on HP, and the axis appears to be inclined to VP. Since it is appears, so you have a beat inclination, and also one of the triangular faces is resting on HP, that is O dash, B dash and C dash. How do I know that it is a triangular face resting on HP? You can see that OC and OB will become invisible because the triangular face O dash, A dash, D dash is a visible edge. That is OAD is a triangular face which is visible, and this entire square surface becomes visible. So this line is beneath that, so therefore this is also becomes invisible, and it is the square of 35 mm side and a height of 60 mm. Since all the data given in the problem is considered and we have incorporated in finding the solution in the manual sketchbook, so hence our problem is right. Thank you.